Hello guys! Welcome back to my YT channel. Hello world, hello Philippines, hello other parts of the world. This is again a senior eternal voice. Guys, I've not yet finished discussing the relationship of the three transport phenomena. Okay, one phenomenon is the momentum, another phenomenon is the momentum transfer, head transfer, and another one also is the mass transfer. So before going further, I already discussed to you, right, some problems on the momentum transfer before, a lot, right? Okay, wherein I use the Bernoulli theorem equation, and then I always discuss this also to you, not 2 days ago, mass transfer, right? So I need to discuss to you guys the pitch coefficient. How can we detect? Mukha sa kong kabush. Wow. Hello guys! No, taga-bush. Wow. Pagami sa kabush. Very crispy kabush. Just I will be showing to you an integral calculus on the mass transfer later. Wait, kasi ko kabush. Pero the basic only not the complex. Hindi kayo, kay init man siya. Wow. Diba? Wow. Kabus. Meron sa water, guys. Wow! Kalamig sa kabush. Hello guys! Yung mga tayo ako nagpagtaon. Chad! Diba? Okay. Ang sugod na tao eh. Okay, let's talk about first momentum transfer. That's basing on the velocity gradient, the difference on the velocity of the fluid or liquid that will move through particular medium. Okay, could it be a pipe again, tanks, vessels, or meter, blah, 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 so on. So, okay. Now, it's in there, we need to apply the Newton's law of viscosity. Okay. Viscosity again, that is the resistance to the movement of the flow of the liquid or a fluid. Okay, so it will always be the counteract force. Okay, resistance from English meaning to resist. The act of resisting is resistance. Okay, like that. So, ito siya pag-interpret. Wow. Viscose force. Viscose force. What's the formula for this? Viscose force. Could it be the viscosity right away? Okay. So we need to correlate so we need to identify first the dynamic viscosity and the absolute viscosity and the kinematic viscosity. Okay, since yesterday that I discussed the Reynolds number, then the denominator of that formula is the viscosity, and we did not know yet what is that viscosity, and I tell you and I told you that this kinematic viscosity, that is correct. Really. I double checked that it's kinematic viscosity really. Okay. So it's gonna be like this na sa dynamic viscosity. Okay, let's go first with yung mga chupa-chucho ha. Yung mga pinaka lang siya, pinaka basics. Dynamic or absolute viscosity. Okay, absolute viscosity. Okay, and then we have the kinematic viscosity. Kinematic viscosity. Okay. Guys, based on my research, because that was how many? That was 2000. How many years now? 21 years ago. Okay, so when I took up my course, right? That okay, so 21 years ago, you could not expect me to remember everything, right? Okay, so of course I do a research review and plus the acquired knowledge, stock knowledge. Okay, something like this. So kinematic viscosity have two formulas. You will agree with me? Two formulas. Okay, kinematic viscosity. So the unit of kinematic viscosity is it's gonna be Stoke, right? Stoke is T-O-K-E because we have the Navier-Stokes equation. It derives there, momentum transfer. Actually, we will use the Bernoulli equation. We're gonna have also the Euler equation. This is all about scientists who discovered equations pertaining to fluid flow or momentum transfer. So we have Bernoulli equation, Euler equation, and Navier-Stokes equation. Based on my research, no. On what I recall a long time ago, I don't understand really the Navier-Stokes equation because there's a lot of differential equations and calculus on that equation, and then the Newton's law of viscosity is more fun because it's very easy to understand. That's normally algebra basic math. But this Navier-Stokes equation and Euler equation, it looks like there's a lot of differential equation. Yes, honestly, I avoided that because nobody wants, complexity of, topic, right? But for me, I go to the most simplest and easy to understand as long as it will yield the same answer. You get the point? So normally we go to that. Okay, so nobody wants a very complicated equations, but in the long run, and finally, it will just yield the same answer. If you can remember in differential calculus, right, we need to solve the area and volume in terms of calculus approach. Then we can also use the algebra approach for that, and it will yield the same answer. Okay, so the purpose is only because we're taking of that particular subject to pass that subject. But in the real world, or for practicality, we will go really to the most straightforward and simplified formulas that will yield the same answer, right? It's gonna be like that. So the purpose only is to know the concept of that calculus thing. But for the real world, medyo dili ka siya ma-apply, though it can be used in engineering design. Okay, but not all will design, right? So for the majority, we go to the basic, the algebra or the mathematics, the math. Okay? So we will we'll go back to the topic of linear equation, linearity of the equations, and then the topic of, what do you call that one? I forgot the term. Polynomial. Okay? Polynomial, binomial, trinomial, it's in there that we will focus. And then a little bit involving with slope. Okay, y is equals to mx plus b, and the b-intercept, the quadrats, and then algebra, the graphing x-axis to x. It's gonna be like that in the basic. And then application of Pythagoras theorem. Okay, the law of right triangle. It's gonna be in there only, and then plus the theta, angle of inclination, cosine theta, gano'n. Diba? Sine theta is equal to, gano'n. Tangent theta, di makalingaw, gano'n, kikuha na. Theta is equal to arc tangent, opposite side over the base. Gano'n. Diba? Sa special, cosine theta, theta is equal to arc cosine, gano'n, diba? Opposite side over the hypotenuse. Ganon. Sine theta is equal to the base over the hypotenuse. The hypotenuse will be the diagonal on the right triangle, right? And then c squared is equals to a squared plus b squared. Then c hypotenuse is equals to the square root of a squared plus b squared. Diba? Yung mga basic lang talaga siya ang we should remember. And also the quadratic equation, positive, negative b, the square root of b squared minus 4ac over, kalimut ko, I think it's gonna be 2a. Pasensya na. Gusto mo na siya ang quadratic equation. Okay? Then, we got a point. Positive and negative b squared minus 4ac. Remember that one? Positive and negative b. Then b squared, ganon, b squared 2ac minus 2ac over b ba siya or a? Nakalimut ko siya sa quadratic equation. Okay, mas muna ako nahinumduman. Okay, so going to this kinematic viscosity and dynamic and absolute viscosity. Okay, so we will remember this one that as you can observe, class, the last name of the scientist will be also the unit of her equations developed, or let's say discovered. Okay, or postulated. Wow, this is the term, right? Postulated. Okay, so it's gonna be this kinematic viscosity. Chararat. Okay, ang kinematic viscosity, as I discussed a while ago, right? Kinematic viscosity is with wings. Small letter v with wings. Okay, ganon. Small letter with wings is equals to, okay, the area, ganon siya, tapos time. Hala? Really? Yes. Ano is the area? This is the length. Sorry guys ha. Length raised to the power 2 dahil siya. Area naman sila kuning length raised to the power 2, right? Okay, length meter man siya, right? So meter raised to the power 2. Area nagap mo siya, pero let's say, let's use length lang talaga ha. Okay, because ang kinematic viscosity, length raised to the power 2 over time. So length is meter, so meter squared per second. Okay, meter squared per second. That's why in the books, it's meter squared times second negative 1. Because that's mean, if you transpose that to the denominator, okay, it will become negative because you put that in the top. That's why meter squared per second negative exponent. The negative there understood to be negative 1. Okay? So this is meter squared, okay, second negative 1. Okay, ganon. Meter. Okay. So this is the unit of kinematic viscosity. Okay? So kinematic viscosity. So square meter S negative 1. Now, so how can we relate this to the Stokes, Mr. Navier-Stokes? So 1 Stokes is equals to 170 Stokes. Okay, so 1 stoke is equals to 100 centistoke. Just remember also in the basic linearity of the length conversion, 1 meter is equals to 100 centimeter. Diba? So ang 1 meter, treat that also as a stoke. So that during your memorization, you will never forget. Okay, 1 meter is equals to 100 centimeter. So treat that also as a stoke, as a unit of viscosity. 1 stoke, same as 1 meter, is equals also to 100 centistoke. Okay, 1 meter is equals to 100 centimeter man siya. So that you will never forget. Okay? Ang imong timanan, ang stoke is a unit of this kinematic viscosity. So, if we have 1 meter is equals to 100 centimeter, so just treat that in the same manner. Okay, 1 stoke is equal to 100 centistoke. So that during memorization, it's easy to remember. Okay? That's very clear. Now, because the stoke rabagid siya, guys, in terms of centimeter, good. I tell you that 1 centimeter squared is negative 1 is equals to 1 stoke, not the meter ba siya. Hindi makalibog usahay because the metric system unit is meter, magod siya. But then, the stoke is in terms of centimeter. Diba? Nakakaloka. Okay, this is the unit of kinematic viscosity. Squared meter second negative 1. This is not the stoke. 1 stoke is equal to 1 centimeter squared as negative 1 siya in terms of centimeter. Niimo siyang square. Okay, now, if you have a problem solving like this in the near future, if the unit is in meters squared per second, negative 1, so, and then you told there to compute for the stoke, and never use this one. You should still convert to centimeter squared, because this is not yet a stoke. This is still meters squared per second that has no equivalent at all in terms of stoke. If you want this to become a stoke, then convert this also to another unit. So 1 stoke is equal to 100 centimeters stoke. Okay? You got the point? O, ganon. So, ako siyang iingon da yun nga centimeter squared, okay, S negative 1 is equals to 1 stoke. Okay, then equal to 100 centistoke. So CS. Okay, CS meaning this is not a cesarean operation. This is centistoke. You got the point? Or this is not a centisecond. This is centistoke. Or to make this more appropriate, this is CST subscript. Small letter T. Sorry. Okay, CST. Ganon. Okay guys, muna na siya itong ipasok sa atong brain cells. Okay. Kinematic viscosity unit standard is centimeter squared per second negative. This is 1 stoke equal to 100 centistoke. Okay, then conversion will follow. If there's meter, if there's feet, there's gallon, there's liter, something like that. You will do the playing around the units. Okay, now, if you speak about dynamic and absolute viscosity, I make this clear guys because when I was in college, I was confused for this. I thought there's only one viscosity. Okay, the term general term, just like paracetamol, biogesic, or paracetamol, medicines, that's all generic to all. But there is a specific for the headache, for the migraine that you will take, that the doctor prescribed. Okay, it's just like that also. This is the generic, the viscosity or the general, but there is still specific, which is the dynamic viscosity, absolute viscosity, and the kinematic viscosity. And take note, the kinematic viscosity is really the important one because it is in the denominator of the Bernoulli theorem of the equation in the Reynolds number. It's not the dynamic viscosity and absolute. And so I want to stress out. Okay, maybe you will substitute directly the absolute viscosity and dynamic viscosity para makuha nimo ang Reynolds number. Mas sayop mo mutaas ang inyong value sa Reynolds number or mo ubos. And then niingon kag turbulent kanili di ay laminar. Okay? So marong mo. Okay? So mo nang ang gamiton di ang kinematic viscosity jud. Okay? You get the point? So through unit, you can identify. And another also identification, another formula for this viscosity, two good siya guys. There are two equations, diba? Kinematic viscosity is equal to length raised to the power 2 over time. And there's also another one for formula of kinematic viscosity. Kung gina siya guys ng actress or actor gina siya sa Newton's law of viscosity. Mo gyud siya ang viscosity nga sikat. Ang kinematic viscosity, not the absolute viscosity and not the dynamic viscosity. Later we will be discuss also a little bit with the dynamic viscosity ha. Okay? So kinematic yun ang mudaog. Siya yun ang rayna o ang hari sa katilingban. So kinematic viscosity. Okay, so kinematic viscosity, another formula is equals to the dynamic viscosity over the density. So, gamhanan ka siya. This is the first time also I observe a formula na pareho siya og term na mubalik rin kung sa siya sa iyang formula. Okay? Diba? It's seldom and very rare that there's an equation and formula that when you break that out, similar word will be there in the formula. For example, density is equals to mass over volume. You will say also, density is equals to molar density over volume. The density will repeat its formula. No, like that. Only this one is very unique. See? Kinematic viscosity is equals to dynamic viscosity. Mubalik ang viscosity ba? Nakuha mo? Mubalik siya in a formula. Wow, bongga. Something like that. Okay? Sikat kayo si kinematic viscosity. Okay, now, kinematic viscosity is equals to dynamic viscosity over the density. Ganon. Second formula of kinematic viscosity. So, guys, you will troubleshoot that the viscosity referring to the momentum transfer is the kinematic viscosity there. It's not the dynamic viscosity. Since that is very useful also to compute for the kinematic viscosity, you should also know that. Okay? But that is only another alternative. Kaya enough naman siya nga may nga length over squared over t. Kasi gari nga na, biya din siya. Kuna lang kay length, sa kuan, pipe, sabi na diha, or area. So, but this other one is dynamic viscosity over density. Okay, dynamic viscosity. Okay. Nakahinumdum ko ani gamay. Gamay lang ha. Charot. Dynamic viscosity, guys, is the mu. Mu. Like this. Okay, mu. Greek symbol. Just like theta, epsilon, omega. Okay, rho. Okay. So, mu over density. Ano siya? Ito ang formula sa kinematic viscosity. Ganon-ganon, chupa-chuchu, right? Okay. Now, ato lang dyan hinumduman ang kinematic viscosity. This is the small letter V nga naipako. Small letter V with wings. That's like chicken joy. With wings. Chicken wings. Something like that. Para makahinumduman. Oh, yung viscosity, mga karoon chicken joy. So, muna na siya ang viscosity with wings. Okay, atong hinumduman. Maghinhinit sa ubay. Ano naman ko sa una ka ng sumukaon ko. Akong i-relate ang mga formulas. Pero dali dyan ako may hinumduman. Buhat na yun ko. Okay? Ganon. Okay, so small letter V with wings. You should remember the chicken wings in Jollibee or in KFC. And then equal to the dynamic viscosity over the density. Ganon. So dynamic, ay dynamic din siya. Ganon. So dynamic meaning movable. Okay? Dynamic, right? Energetic or movable. Okay? Or in motion. So that is dynamic. Vibrant, active, energetic, okay, movable. Okay, so those are the terms having the same meaning with dynamic. Okay, so over density, something like this. Or active, that's dynamic also. Okay, so muna na siya two equations, memorize kay kalas. And then we go to the dynamic and absolute viscosity unit. This is the term that confused me a lot. Okay, because, oh my God, just poa. We pronounce it as a poa. Okay, 1 poa. Okay, and there's also 1 centi. 1 poa is equals to 100 centipoa. Magaganon ba? Okay, poa is derived from Mr. Puchul. This is also a scientist. Nag-discover niya ang dynamic viscosity, Mr. Puchul. P-O-I-S-E-U-L-L-E. He is a scientist that discovered the existence of absolute and dynamic viscosity in fluid flow in momentum transfer. That's why the unit is 1 poa or poise. Ikabasa niyo guys, poise, pero hindi ka po ng poa. 1 poa. P-O-I-S-E. You get the point? So it's gonna be like that. So what's the unit of a pois? So 1 pois, or P-O-I-S-E, or poise. Okay, but the pronunciation is pois. Correct pronunciation, not poise. Okay? But the symbol is capital P. Okay? And then if it is centipois, just add small letter C, just like centistroke. Just add letter C, right? Then 1 pois. 1 pois is equal to 1 Pascal second. Okay? So 1 Pascal second also equal to kilogram per cubic meter second. So kanina siyang inunduman mo per me. Tulo ka unit, 3 units involved in dynamic and absolute viscosity. The Pascal second, the kilogram per meter second, and the pois. Okay. Now, in kinematic viscosity, ang imong timan-an, ang stroke region o kaning usa. Okay? 1 stroke is equal to 100 centistroke and centimeter squared S negative 1. Kaya kanang meter, daog naman na sa centimeter, parihara man na siya tanong, is na naman din mag-feet, unit man na siya sa length. So, duha rin siya memorize. So, nakatulahi man to siya, kaya may Pascal, dapat yung kilogram. So, tulo siyang yung i-remember. You get the point? So in short, absolute viscosity and dynamic viscosity have 3 units to remember. And kinematic viscosity have only 2 units to remember. Okay, now we need to emphasize this because during the substitution in your Reynolds number, it must agree the units in consistent manner so that you can cancel that out. Because you cannot cancel the dynamic viscosity, if you use the dynamic viscosity in the denominator of the Reynolds number, it is wrong. Okay? It should be kinematic viscosity, not dynamic viscosity, and not the absolute viscosity, because viscosity has so many types. Not on there is a general viscosity, so there is still absolute, dynamic, and kinematic. Okay? That's clear. Before going to heat transfer. Right? And now, if we speak about viscose force, this is only the same as viscosity. Okay? Okay, force naman po ng viscosity, as I told you, that is the resistance of a fluid to flow. Okay, so if it will resist, that is the force that resists to counterflow or to counteract the motion of the applied force. You got the point? After you make the free body diagram, the FBD. Okay, so you will establish, oh my gosh, there's an applied force. What will be our counter force for this? And then the net force. Okay, summation of all the forces with the consideration of the negative sign and positive sign. That is the net force. Let's to siyang kuan difference sa force gradient or force difference. Kaya imo may subtract ang force 2 minus 4, 1, or the final force minus force initial, in which ang final force mo to ay resistance. Okay? Since that is fluid, okay, no need to say friction. But if it is in the surface, in the ground, or in the floor, you will use friction. You get the point? Solid, you will use friction. But for liquid and gas, use the term viscosity. Not the fraction, but it has the same purpose to counteract the applied force of a fluid, liquid, or a solid, something like that. That you will be able to apply the force. Applied force or input force, just basically the same. Okay? And then the output force. Okay? The output force or your final force. Okay? And then the counteracting force will be your viscosity, okay, or either the friction. But these two quantities are both resistance. Okay? You get the point? Both resistance generally. This viscosity and then this friction also. That's why in physics we need to use always the friction laws. Okay, the friction laws, blah, 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 so and so. When you throw a ball in a cliff, in a projectile motion, you remember that one? Motion, problem solving. Okay, if the car going to the rotunda, what is the time they will meet with each other? Ganon. And then if there is a boat A, boat B, ship A, ship B, it will travel to 10 nautical miles per hour. What will be the time when we reach each other? When they approach each other. So this will be applied to this also. Okay? You get the point? And then we know also that, oh my gosh, 1 nautical mile per hour. So, how many nautical mile in every feet? Diba? So you will say 1 nautical mile is equal to 5,280 feet. Okay, and then the rest will follow. You can convert the feet into meter, centimeter, inches, millimeter, centimeter. Muna yung mga identification sa mga navigation problem solving. Navigation through the boat, B-O-A-T, and ship is H-I-P. In the sea, in the ocean. Okay, so muna ang mga velocity there. Imong gamitin ng unit, nautical miles or nautical miles per hour velocity. Okay, velocity because they're referring to the orientation. Could it be the west, north, east, south, like that? So it should be like that, right? The direction matters a lot in navigation. Okay, that's in the nautical. Okay, perspective. And now we go back to here. So dynamic and absolute viscosity. Right? Klaro na siya ha. Okay, 1 pois is equal to 1 Pascal second. Okay, and it's equal to kilogram meter per second. Now, you remember momentum, right? Momentum, mass times velocity. And you remember also impulse. Guys, don't forget the impulse. I remember this in the board examination, in the general engineering. Impulse topic came out really, and I was shocked. Okay? And it was so lucky that at that time I bought general engineering review book. Okay? The Excel Reviewing Center, the yellow one and the blue. Oh my gosh, it's basically the same. Really, the given only are changed. Oh my gosh, perfect. So, not perfect at all on that particular problem only. This is basically the same. Calculate the impulse. Impulse is equal to force times time. Okay, and then momentum is equal to mass times velocity. Okay? So it's in there, you will discuss the law of conservation of the momentum, okay, and the law of conservation of the kinetic energy. Remember, the law of conservation is not limited to chemistry. As I always talk over and over again, law of conservation of energy, law of conservation of matter, law of conservation of mass. But in physics, we have also law of conservation of momentum and law of conservation of kinetic energy. And we should understand between elastic motion and inelastic motion in studying momentum. Okay? So this will come out in the board examination, in the general engineering. Okay, you get the point? Adyo ninyo kalita ang impulse o ang momentum na adyo ni siya pero ni oy. Okay, module. Okay, going back. So, ganun siya. Now, isa mo ito itong standard formula sa momentum transfer. Okay. Kaloka. So, that is momentum flux. Momentum flux is a shear. Ganun siya. Okay, then, guys, this is kinematic viscosity. So, kinematic viscosity. Okay, and then dV, dy. Kaya maglagot siya po sa una. Antod ka rin maglagot ko. Kaya ano maglagot ko? Okay, kung ano yung momentum transfer. Nawa ha? Di ba niyong ka nga, muna siya ang shear stress. Nakakaluka, shear stress is also a pressure. Really. So, di ba, pressure, ang definition sa pressure is the applied force, the perpendicular force applied per unit surface area. Okay, that's the pressure. And then, the pressure also is a stress or a shear stress in this manner. That's why it has the same unit. You get the point? And then it is kinematic viscosity over the dV dy, or sometimes delta V delta Y. And this Y, nakakaloka. This is sometimes interpreted also as L, or this, okay, Y, L, Z, and X. Okay, because me as a student before, I refer so many books. Then I can identify what happens. This is not consistent. Of all the transfers, heat, mass, and momentum, this is only the transport phenomenon, or one of the transport phenomena, okay, that has so many variables expressed in the denominator, but it has the same thing. Okay? Sometimes it also L, DL, denominator. Sometimes DL, DY, DX, DZ, nakakaloka. Iilis-ilis na niya, depende sa author sa books. Get the point? No, maglibog ko ano niya, when I was in college, maglibog ko sa momentum transfer, really. So, malipay na ko kung muditso na siya ka ng mga volumetric flow rate, mass flow rate, dali naman kasi yung overall material balance. But mag-involve na ganun siya mga ingani ng mga pangkuhan, limits from 1 to 2, ganun. And then, you will integrate, maglibog na yun ko, labi na mo involve the viscosity. Sa una, okay mong nabay na ng klaseng viscosity. Not all engineers know different types of viscosity. What we understand before is viscosity alone, as general. Okay? You got the point? Bisag saan pa lang yung pangutana ang mga engineers karon? Some of them don't know what is absolute viscosity, what is dynamic viscosity, and what is kinematic viscosity, because that is not their interest, because they are already working in the field. Okay, of course. But what I mean, when they are also, we are not familiarized that there are 3 types of viscosity. Okay, muna siya natabo. Muna, kaya mo ko bang lakwa, dagang kiwang. Okay, muna na itabo karon guys. Okay, so ako yung i-express nga mauni siya, gano-gano, na virtue. Okay, okay guys. Muna natabo ha. I will never use the microphone at this point in time. Let's see. Because kapag ko sa microphone, fairness. Okay. So, dV/dy. Okay, muna na siya ha. The kinematic viscosity muna yung tupad. So, muna siya ang momentum transfer flux. Okay? Yeah, shear stress dayon. Charot. Okay, now, we have viscose force, di ba? Ang viscose force formula, diyan na naman tayo. Or, okay, viscosity. So, we kigas ka na, mungot ko ng viscosity. Okay? So, is equals to shear stress. Okay? Ganon, shear stress times the area. Ganon siya. Mauni siya tabo. Okay? Shear stress, viscosity is equals to shear stress times the area. Now, kung nakay area nga, naman kayo ka ng tau. Okay? So, imong tau na naman kay V dV over dy, right? Ay nasa kay area. So, ang imong kinematic viscosity, ang saman to siya, butangan mo units. Or bisag nila mo butangan units, okay ra siya. So, kinematic viscosity is equals to the velocity over nawa, ang y mo, L na sad siya. Length. Sumura na siya x-axis. Okay, so L. Kaya ang L mo may dali gamiton sa kuan, mga kanang mga convert, kanang mga derive ka kay mo na pirmi. Nakabantay ka diba katong kinematic viscosity L squared over T baya. Okay, katong sa mga kuan sa mga volume, di ba? Katong L sabi yung gamiton dayon sa concentration moles per liter, diba? L dayon ang ibutang. Okay, muna technique. Okay, then area L squared. Then our good ang L squared makancel dayon siya. So, mahimo din siya, kinematic viscosity is equal to VL na lang yun siya. So, muna din mong shear stress or initial force, inertial. Grabe, no? Nakakaloka talaga, no? So, shear stress is just also equal to inertial force. Kaloka. Nabi inertial force. So, that is derived from the first law of inertia. That whenever the stress is applied, okay, the body will continue moving unless acted by a net force. That is the first law of Isaac Newton. That's why I registered in my brain cells. I memorized it in high school. Okay? So that is the first law of inertia. Whenever a stress is applied to a moving object, the object will keep on moving unless acted upon by the net force. Okay, law of inertia. Okay, so this is our inertial force. Muna na siya. Kanina muna na siya, guys. Okay, kinematic viscosity and velocity times the length is equal to our shear stress. Okay, ganun-ganun na siya. Sa ito pa, shear stress also is equal to the viscous force. Kaloka, no? Grabe kaya ang momentum transfer. Sige na lang. Okay. So, now, makita ka momentum diffusivity. So, ano sa yung pagkuha ni mo ang momentum diffusivity? Na muna ni Ron. Momentum diffusivity. Kung saan man mo pagkuha ni Ana ang higayuna. Okay, so kung nakaykuan, imo na siya i-divide kinematic viscosity, viscosodynamic viscosity over the density. Okay, so muna nimong gamiton nga momentum diffusivity. Charot. Okay? Muna na siya. Okay, sa momentum transfer guys, imong gamiton is momentum diffusivity. Sa heat transfer, thermal conductivity. Sa mass transfer, okay, mass diffusivity, which is equal to the diffusion coefficient. Okay? Muna siya yung mga timan ng mga constant pang tupad sa kilid. Di ba? DVDY, DTDL, DT-kuan. Nga ba? Okay? Mag-integrate man na siya kung nakay mga values sa initial and final mo na magkuan din mo times times din mo dito dara butangan din mo ln kung follow atong nga rule sa differential, di ba? ln a ln b minus din mo siya ln kung ln a minus ln b mohimo na siyang ln a over ln b, di ba? In the differential or integral ananaon din na nimo din siya kung may mga limits. Okay, hindi mo ko ganahan ng ana. Okay, ari mo jud ko sa algebra approach. Okay? So, pwede rin na siya ato sa subject sa general engineering kay mga ingana man gyud ang ipang-solve dito mga calculus, chupa, chuchu. Okay? Muna na siya. Maghatag ako ng problem ha. So, asan itong problem solving na tadayon para mailubog. Diba? So, saan na ito pag problem solving ni ining higayuna? Siyempre, kuha din na ito itong mga example. Wow! Wow, kita 2,000 do. 2,000 ba? Chemical Engineering Board Examination. Wala mo ko kita eh. Okay, muna siya akong example naman ninyo ha. Kani siya guys. Ako rin suot na rin. Kani siya. Kani siya. Char. What is the rate of heat flow through a glass window? Charot! Grabe na kayo mga professor mga kabuang. That is 2 meter times 3 meter times 1.4 centimeter thick. Hala. If the outside temperature is 22 degrees Celsius and the inside temperature is 25 degrees Celsius and the thermal conductivity is 0.84 joules per second meter degree Celsius, what is the power needed? Kaloka. Na ang ano nga problem, personally, maglibog ka primero kay power dayon. Wala, ay mo na hinumduman sa power. Oh my gosh, power is applied only in electrical energy or electricity, practical electricity na mag-image. Power is equals to work over time. Ganun, di ba? The power is equals to the charge Q times the voltage. Do you remember that one? And then power, there are a lot of formulas of power, if you can still remember. The relationship also with the voltage and the resistance, you got a point? Through the Ohm's law. And then you substitute that there to the Q. Because since you know also that the current is equal to the charge that will pass in a certain time. Right? Current is the certain charges of an elementary particles, could it be electron, proton, and neutron, that will travel per unit time. So, Q is over, that is current. Okay, so 1 ampere is equal to siya, chuba chuchu, 1 ampere is equals to coulomb over second. In coulomb also, 1 coulomb is equals to ampere second. Right? Is the point? Nakakalukan, no? And joules over second is also the watt. Kaya tungod ra gani siya sa iyang formula. Di ba na iyong kung power is equals to work over time. And power is an energy. Electrical energy. Now, so since power is equals to work over time, the unit of work is joules. And time is the denominator. So that is joules. Ika na mong ingon ko diretso nga 1 joule per second is equal to the energy, power. Okay, or watt. Di ba nakakaloka? Ang watt, nikalit rin siya og joule. So diha na siya gikuha. Okay. Ano din ang problem? How many calories that the electrons will flow? Masya ka, kaya anong calories ang ipangita? Nga dili na siya pinili applicable ng calorie sa term sa mga electricity. So ang purpose na nagilibog ra gyud ang examine, isukod ra siya daw kamo ba gyud siya mo tuki sa kanang mga unit, nasabtan ba gyud niya nga ang kanang calorie pareho ra na siya sa watt. That's still energy, but it is more on the biological substances. Okay, and then the electrical power or the watt is more on the electricity. Then kung imo jud ipa-convert, ma-convert gyud na siya kay naman tay 1 calorie is equals to 4.184 joules. Okay? Muna siya kanang mga involved mga motor, electrical motor, pump of a machine, equipment, rotating equipment. The problem will say how many horsepower that this motor will in 30 seconds. So this it's in here that you can compute because 1 horsepower is equals to 746 watts. Using the formula of power is equals to work over time. So it's in there also. Then we don't know kung mukatok ang questionnaire. Mingon siya nga, how many calorie, how many of calorie of energy that this motor pump deliver? In the first place, this is not applicable for that type of situation, but we don't know because expect the unexpected in the examination. Okay, so it's possible because we can convert that from joules. Okay, you get the point? Because 1 watt is equals to 1 joules per second, and 1 joule is equals to 4.84, 1 calorie is equals to 4.84 joules, and 1 horsepower is equals to 746 watts. So dito ka magduwa-duwa sa units. So makuha rin mo siya perfectly. Okay? Ganon. Why is it perfectly? Because it's basic. Okay? That is not complicated units. Okay. What na abot atong mga Ørsted, atong mga max flux density. Yung anong good sa chemical engineering mo kuan jud ka pag-ayo sa mga mutuki jud ka pag-ayo. What is the unit of the magnetic flux density? Di ba? Dili siya common. Okay, but I studied that when I was in college. Okay, because it applies in the wave of a photon or a light. Okay, but the discovery of Mr. Max Planck. Okay, he discovered the photon energy of a light. Okay, something like that. It has a frequency. Ano. O diba? Special. 1 Ørsted. Grabe na no? Ørsted talaga. Okay, Ørsted is a unit of magnetic flux density. Charot. Ganon? Really? I'll just review that, the magnetic flux density in relation to the magnetic field strength. Okay, ganun. Dito na mo appear ang katong mga Weber, unit na Weber, W-E-B-E-R. Scientist also Mr. Weber. Almost all guys, the unit derived from the discoverers. Okay? Kay kang Mr. Weber man sad na siya. Ang current kay Mr. Ampere pud na siya. Okay, i-discover niya ang current. Halos tanan derived sa ilang last name. All other discoverers derive from their last name. Okay? So, muna natabo. Okay, ganun siya. Charot! Okay. Now, going back to this, how can we solve this one? Murag, kuan ra ni siya sa inyo kasi, murag ikuan ra ni. Charot! Diba? Okay? Okay, class? Any questions so far? Charot. Any questions so far so that I can explain? Charot. Wait, pinalpin na lalim. Okay, na. Ukot na akong pinalpin, guys. Ay, nako! Woo! Nako, Jun. Charot. Red pentel pen, what does it mean? Okay, red. Look, red. Ano tong red? Red color has a wavelength of 670 nanometer frequency. Wow. Grabe, no? I still remember. 670 nanometer wavelength. My gosh. Kaloka. Oscillation per second is the unit of frequency, ha? Oscillation per second, vibration per second, and cycle per second are the units of frequency. Okay? These are very useful in the calculation of the energy of the elementary particles. Could either be electron, proton, neutron, positron, photon, okay, fermions. Okay, you remember that one? Fermium and boson and quarks. Di ba? Ang kinagamyan katong dapat siya na siya kinagamyan. Di ba? Ito nga. Sa nucleus na siya atom, di ba? Inside the nucleus and there's a proton. Dapat siya pinakagamay. The most tiniest particle. Dapat siya pinaka sub-atomic particles. Muna akong ipangyaw-yaw karon. Okay? You get the point? Fermion. Okay? Then quarks and lepton, Lepton, mga sub-elementary particle within the proton and neutron, ganun siya, okay? Lisod kayo, elementary particles, okay? At ito siya ma-apply dito, okay? Na mga situation, okay? So, what is the rate of heat flow? Nandiyan na lang tayo, okay? What is the rate of heat flow? Guys, rate of heat flow is just the same with rate of heat transfer, rate of heat transmission. Okay? So, these three terms will be used interchangeably. Okay? What is the rate of heat flow? What is the rate of heat transfer? What is the rate of heat transmission? What is the rate of heat transport? 4. Okay? So, naraanin niya ang igamit sa problem. But ang pinaka-common dyan no, ang kaning flow, ang transfer. Okay? It's seldom to use the transmission and the transport and the transmission. But basically the same meaning. Okay? What is the rate of heat flow through a glass window that is 2 meter times 3 meter? Ganun siya, 2 meter. Okay. Now, we will go to the formula of the heat flux. Heat flux is equals to dq over dt. And then since we are only interested with the q, it will become just q. Right? And through mathematics, cross multiplication, ato na siya mukuha sa numerator sa picas. Okay, so q is equal, what is the heat? Is equals to the thermal conductivity times the area times the change in temperature. Okay? Change in temperature, delta change in temperature meaning T2 minus T1. If there is a delta sign in the T, that is change, difference, gradient. Okay? Muna siya ang mga buot ipasabot ni Ana. Ayaw niya yung edit so og substitute kay difference yun na siya. Okay? O di sad na siya net. Nga imong i-add ang duha. Di sad na siya total. Okay? It's always change and difference or gradient. Okay? So, kay heat transfer basing on temperature gradient or temperature difference from high temperature to low temperature. Okay, so delta T, ganun siya chuba-chuchu. Okay, and then ang L na pod. Balik na pod ang L. So, swapang kay ning L, magbalik-balik ko siya per sa denominator. Okay? Now, ang L kay magbalik-balik mo siya per minasa din siya sa formula dito sa thermoresistance. Nausab na ang term. Di ba? We are used to hearing resistance only. But if we are referring to heat transfer, this will become thermoresistance. Because of the word thermal. A combination between thermal and resistance, it will become thermoresistance. Thermoresistance is equal to the length over the thermal conductivity. Okay, ganon. Okay, you get the point? You have to add thermo because this is heat transfer. Okay, it's not the general R only used in Ohm's law, the VIR, nor it is only not the resistance used also in mass transfer. Okay, nakatong minimum difference of the resistance, ganun chuba-chuchu, okay, kaloka, change in concentration over the diffusion coefficient. Lahi sa di siya dili-ari. Pero common siya ang mga diffusion coefficient, thermal conductivity, kaning momentum viscosity, mo siya ang mga constant na imo siyang i-multiply. Okay? Sa kilid-kilid, sa numerator. Mo nimong timan-an permi. I-multiply ko na siya sa kilid-kilid sa taas sa numerator. Okay? Mo yun siya permi ipakapin. So, di mo siya kalimtan. Okay? Ganon. Or else, marong na jud ka kung may mga diffusivity, chuba-chuchu, or mga coefficient, or mga constant na ipares nimo sa mga change, chuba-chuchu. Okay, ganon. Okay. Ang L, guys, magdepende na siya kung ang kuan dito higayon na thickness ang ipag-usapan. Pero sometimes pag ang ipag-usapan niya ang mga length gyud siya. So muna mahimo na siyang length or thickness depende sa problem. Basta horizontal axis gyud siya. Okay, kaya ang thickness kay horizontal man jud ang thickness, di ba? You get the point? Ya, kung imo siyang i-vertical, ini katuyok nimo mo horizontal naman sa Japon na siya. You get the point? Just like this, I have this speaker. I have this length from here to here. Actually, this is the diameter because it's around. But this is also the length, okay, of the base of this speaker. And then kung imo siya ituwad, mura magyapon na siya, length na magyapon na siya. Itutuyok nimo ang orientation, that's still length. And this is also the thickness. Okay? Look, this is because there's no other, thickness for this. The thickness will also become the length, will also become the diameter. Munang mahibong mo nga sa problem, mugamit siya bisag dili siya thickness. Okay, maura man gyapon ang gi-refer niya. Okay? Yan, be careful ka kay nang sa mga shape nga lahi ba ya. Okay, sama na mga cube, mga sphere, mga sa panadiha. Okay, mga trapezoid, mga rhombus, okay, mga ganun, mga spherical. Lahi na ba dito ang thickness? Ang length, so dili na ito nimo. Kani, normal rin siya nga dagan. Tama ba ito? Ana naman siya through a glass window, ganun. Wala man siya window, di ba? Ang window, kung ano naman gina siya perni, square or rectangle. Di ba? Ano siya? So, i-specify na din siya ang thickness. So, na siya thickness, sige, ibutang dyan niya ba? Kung ang problem, wala yung, dili siya i-stating imo i-troubleshoot, ang length mo ni siya. Mubase ka sa horizontal x-axis. Sa length yun niya, dili sa height. Okay? Sama ng rectangle, ay pagkumpiyansa sa rectangle. Okay? Kaya ang rectangle raba, gamay raba yung kuan, yung height. Rectangle, length times width, the area, right? So, if you use the height, gamay ra ba siya ang length dako. So, masayop dayon ka. Kung rectangle ang gi-refer ani nga rate of heat flow. Get the point? Kung what siya ni given of thickness. Okay? Unless specified that there is thickness, use the thickness as your L. Ana na lang. Okay? Term specific. If there is a thickness, then put the thickness. If it is not specified, use the length, which is the horizontal x-axis. Okay, not the vertical. You get the point? Para we should agree with each other. Ganon. So that is Bislish, Bisaya and English. Okay, so what is the rate of a heat flow? So muna siya. So the rate of the thermal conductivity is equal to, tanawa, ang kuan, di ba? Ang unit sa thermal conductivity, watts per meter degree Celsius. Since we know that 1 watt is equal to joules per second, the unit of thermal conductivity becomes joules per second meter degree Celsius. Ganon. Kahit ang tuyok niya, magkuha siyang energy na in terms of joules. Dili na siya in terms of watts. Dili man siya more on the electrons flow, on the electrical cable path. Ang yung type sa problem ba, muna marunong ka siya, i breakdown on watts. Okay, actually, kung ano naman siya, 0.84 watt per meter degree Celsius. So, that's the problem, nikalitra siya of joules per second meter degree Celsius. But if you try to look in the table, in the handbook, it's expressed in watts. And then, ikasolve nimo, imo din ang ibungkag dayon na joules per second. Pero ang standard sa table, dili ingana. Okay, you got the point? Ikaw dyan ang manage to convert it directly. Okay, wala gihungit ba, wala gi spoon feed sa libro. Ikaw dyan mo think farther. Okay? You got the point? Ganun siya. Okay, then thermal conductivity is equals to 0.84 joules per second meter degree Celsius. Okay, times the area. So, area, kaya naman siya, 2 meter, 3 meter, 1.4 centimeter. So, there's thickness involved here. Okay, so imong imagine nun, 2 meter times 3 meter, hala, dili siya equal, mas gamay na, kung yun siya, rectangle, ang window. Or else, it become a square. Equal ta siya 2 meter times 2 meter, di ba? Dili man. So, this is rectangle. Glass window. Alam nga mag-trapezoid ang window. Okay? You get the point? Alam nga mag-sphere, na this window nga sphere, na window nga trapezoid, rhombus, or cube, di ba? Wala. So, ato ka sa pinaka-basic na rectangle. Ganon. So, area. Okay? Length times width. Okay? So, length times width is 2. Be careful also na, ang problem, gihatag rin, no? 2 meter, 3 meter by 1.4. Ayaw ni ibutang sa area, ha? Okay, this is volume. Ang imong i-times ano niya sa area diri ang 2 meter na gyud og 3 meter ay ayaw kabitik nga gisumpot dito sa problem ng tulo ka number. Masig imo siya i-times diretso. Kay mao iyang dimension. You got the point? The dimension is 2 meter by 3 meter by 1.4. That is length times width times thickness. That is volume, not area. Now, ang atong formula area ra ba ay apil ang 1.4 nga thickness. Adto na siya sa denominator. So, area is equals to 2 meter times 3 meter length times width, right? Okay? Unless specified in saan siyang klase, kung ba, spherical ba siya, whatever, delete man. Okay? So, change in temperature. This one, guys, this is Celsius. Use Celsius, not convert to Kelvin because your unit of the thermal conductivity is already Celsius. Okay? So, as is, do not convert in Kelvin. Agree na din siya diretso sa unit pa lang sa thermal conductivity. Okay. So, 25 minus 22 over thickness, ng dimension siya, 1.4 cm, convert that to meter. Because all are in terms of meter. Kailang wagin siya mulubog. The same units in the numerator and in the denominator. Okay, so it's gonna be 1.4 cm divided by 100 cm. Pila siya? Kaloka. Okay, 1.4 divided by 100. So this is 0.014. Okay, meter. So this will cancel all. Muna natong heat. Okay. So in this manner, guys, we need to be patient. Okay. So to cancel out the unit. Okay. Meter, cancel. Celsius, cancel. Okay, ganon. So what we left here, class, is gonna be joules. Okay, but there's still another m here, m squared, and then this will be cancel, another cancel sa siya gapon. Okay, cancel. Okay, so ang mahabilin mo na gayon na is joules per second. And joules per second is the rate, because there's a numerator, and the energy per rate, and this is the rate of heat flow or rate of heat transfer. Okay, heat is in terms of energy, and the unit of energy is joules. So that's why joules per second ang nahabilin sa inyo. Waragon, akong gipang cancel chuba-chuchu. Okay? Nahabilin joules per second. So joules per second is really the rate of heat transfer or the rate of heat flow, the rate of heat transmission, and the rate of heat of transport. Okay? Ganon. So, or the rate of heat loss or absorb. It depends on the situation, okay? So, 25 minus 22, okay, times 2 equals to times 0.84 divided by 0.014 equals to. So, we have 360, something like this, okay? So, 6, review for the second time. 25 minus 22 is equals to times, okay, length times width times, okay, 6, okay, times 0.84, okay, divided by, pila siya. Atong i-divide siya sa 0.014, 0.014. Okay, so we have 1080 joules per second, and this is also watts. Okay? Pareho naman na siya. Okay, 1080 watts is just 1080 joules per second. As I said earlier, 1 joules per second is equals to 1 watt. Okay, so 1080 watts. Or if you don't like watts because you don't feel that one is more applicable in the electricity part, so then you convert that to joules on calorie to make it safe, or you can convert that through British thermal unit BTU, or you can transfer that to another unit, the ERG, ERG. ERG, kasi ng ERG sa Sotero. ERG, ang ERG mo na siya katong dyne times centimeter. Okay, dyne times centimeter, pareho siya atong Newton meter. Okay, unsa man ang dyne? So ang dyne mo na siya ang gram, okay, gram centimeter squared, okay? Kaya naman tayo kilogram meter per second squared. Nasa mo na siya ang Newton. Ang atong dyne, yan ang higayuna, is gram centimeter per second squared. Okay, but in terms of centimeter and grams, muna siya ang dyne, D-Y-N-E, times centimeter. And dyne times centimeter, 1 dyne centimeter is equals to 1 erg. Now, if you try to convert 1080 watts to erg, you can do that by having first the joules per second, and then joules to the erg. Okay, if the problem will say, what is the heat energy of transmission or transfer in erg? O nga. Ngita din sa handbook. Libro pakli. Wala. Uban lisod pa kayo. Wala. Time consuming na kayo. Memorize na lang yun na muna ang erg. Okay? Erg, dyne, centimeter. Dyne is equals to grams, centimeter per second. Para makuha dyan yung unit. Okay? Got a point? Muna siya na itabo. Okay? So, daghan siya mga units ang energy ha. Okay? So, 1080 watts ang atong answer ni Ining na. Okay, anybody? Any question? Any questions so far for our problem solving? Okay guys, I will explain. Nothing? Okay, if you like this video, you can comment down below in the comment section. If you think you are not subscribing to my YT channel, then you can subscribe, and you can also click the notification bell for some newest updates. I'm gonna Singer. Eternal Voice talks about OSH, science, okay, health, lifestyle, and chemical engineering, and also personal vlogging, and also Biritan. Okay? Biritan singing moment. Charot. Okay? Thank you so much. Bye-bye everybody. God bless everybody. Okay. Charot. Kaloka.